So if I want to write the equation of a line, okay, I can take the slope and y. I can find it in the slope y-intercept form, or I could write it in the point slope form. Regardless, if I have enough information like the direction and some position, I know that this linear equation can be written in the equation form, or this linear relation can be written in an equation form. Now, what I could do is I can just draw this in. I have point at 3 over 5 up, and I use my slope of 3. Okay, 3, 1 over, okay, and I can draw my line. So that's what my relationship looks like. Okay, and I have my slope of 3. My slope triangle can show up right there. Okay, I've got a 6:2 ratio for my slope, and that represents my graph. So what does the equation look like? Well, I could do this. I can solve for the equation, the y-intercept equation, by doing this. I know the slope, so 3x, and I don't know the y-intercept, but I can find the y-intercept by using the property that any point on the line has to fit into this equation. So I can choose any point on this line. I could use this coordinate here, y equals 5 when x equals 3, and solve for the y-intercept. So y-intercept, I get 5 minus 9 is going to be -4. So I can do that. Y equals 3x minus 4. Now in grade 11 and 12, we should start transitioning towards the point slope form. And the point slope form looks like this. And this is the point slope form is the form we use in calculus almost exclusively. And the point slope form, x minus x naught plus y naught, where x naught, y naught represents some point, m represents slope. And I can do this. If I have the slope 3 and I have a coordinate, x is 3, y is 5, I just plug it in like that, and then I'm done. That's it. I just put in my point, my slope, and my point, and I'm done. Now, if you want to put it into the y-intercept form, we can just multiply this out. Okay, so this is done. I'm finished there. But if I want to multiply this out, I get -9 plus 5, and I get my y-intercept form as well. So this is also useful for generating the y-intercept form. Okay, so we could do this. This is kind of the way you may have been originally shown. Just plug in, set it up as y-intercept form, and then plug in and solve for b. If we just set it up as point slope form, we can leave it like that, or we can expand it and find the y-intercept form. So this is much more flexible because we can really just leave it in the point slope form. So here we have a y-intercept and a point. So I can put it into point slope form, or I can use the y-intercept form. So I'm going to do the y-intercept form here. So here I've been given the y-intercept. I don't have the slope, so I'm missing m. So there's my y-intercept. I'm just going to write it as -1. And so do I have enough information here? 0, -1 is my y-intercept. 4 over 3 up. Can I draw a straight line through those points? And the answer is definitely yes. So all I need to do is figure out slope. Now, if I have a graph, I can just count slope. I got 4 over, 4 up. Okay, so that I know my slope is equal to 1. I can solve this algebraically. So that's one way. I can solve it algebraically by plugging in the coordinate. Now, I have two coordinates here. If I plug in 0, -1, it's not wrong. But when I plug in 0, -1, notice what happens. M times 0 minus 1, I get -1 equals -1. I didn't solve for m. Okay, so it's not wrong. -1 is definitely equal to -1. So it's never wrong to plug in a coordinate. However, it didn't solve for anything, so I need to use the other coordinate. So y equals m times 4 minus 1. So 3 is equal to 4m minus 1. So I get 4 is equal to 4m. M is equal to 1. So what I see in my picture is confirmed algebraically. And I get y equals 1x minus 1. Now again, I said that the point slope form is the form we want to start using, so I'm just going to plug it into the point slope form. I don't know the m. I know the point that I know is going to be, let's see here. Well, let's plug in. Well, it doesn't really matter what point I'm gonna use 4 plus 3. Now I need to solve for m. Now if I plug in 4 and 3 here, I'm gonna get 3 equals 3 again, which isn't useful because I can't recycle the same information. So this information was used to generate the equation, so I need to use the other coordinate to solve for m. And when I solve for m, I get -1 equals m times, it's going to be 0. Okay, x is 0. Y is -1, so I end up with that. So I end up with -4m is equal to plus 3 is equal to -1. So -4 is equal to -4m. And I end up with the same equation, or same result, m equals 1. And then I just leave my equation in the point slope form. Okay, because there's nothing wrong with the point slope form. Okay, now if I was asked what's the y-intercept, I can just either plug in 0, or I can solve for, I can just expand and combine like terms there. Okay, so here I've got another coordinate, -3, +9, -3, +9, somewhere up here, 5 over 3 up. Okay, if I'm given those two coordinates, I should be able to draw my straight line relationship. Okay, so again, I need slope and a point in space here. So I'm going to do this. I'm just going to find out my slope first. Okay, between those 2 points, okay, I have a change in y. It's going to be 2, 4, 6. So -6. My change in x works out to be 6, 8. So plus 8. Okay, if I want to use a formula, I can use y2 minus y1 over x2 minus x1. I end up with 6 over -8. Okay, in either case, I get a negative slope, -3 over 4. And then once I have my slope, I can put it into the slope-intercept form and solve for b, or alternatively, which is what I prefer, is I'm going to put it into the point slope form. And I'm going to use either point, so I'm going to use 5 and +3 as my coordinates, and I can just leave it like that. Okay, here I would have to actually solve for my y-intercept, -3 over 4. I have to plug in one of these points, so I'm going to plug in x is 5, y is 3, and then solve for my unknown b value. Okay, so here my unknown b value works out to be, so 3 plus 15 over 4 is equal to my b value. Writing this in an improper fraction, I'm going to get 27 over 4. So this equation, and y equals -3 over 4x plus 27 over 4, these equations are exactly the same. Okay, the blue one is certainly much easier. Okay, for these ones here, okay, put them in Desmos and graph these and sketch the graphs of these.